Hi guys, good morning. As I promised before, I have come up with the fundamentals and prerequisites of SAP BI, and I want to quickly run you through the document that I have created for that. Fundamentals of NetWeaver Part 1. So we are going to look into the fundamentals of data warehousing and business intelligence, which is created by me. Now we will have a short history, SAP history. SAP was founded by 5 former IBM employees in 1972 to develop a standard business application software with an idea of processing business information in real time. The company SAP GmbH was started at Mannheim, Germany. In 1973, R1 was rolled out as the first financial accounting software, and in 70s R2 was rolled out. In 90s, SAP R3 with the client server architecture and GUI which would run on almost any of the databases and on most of the operating systems. So R3 heralded a new era in enterprise computing, moving from mainframe to 3-tier architecture like database server to application server and the user interface, which is also called as presentation server. So this is the 3-tier architecture which SAP is built on, and this had become the industry standard from 90s, since 90s. In 21st century, for SAP started with the enterprise portal and role-based access to business information. Evaluation of SAP BW. In 1997, the first version of SAP product for reporting, analysis and data warehousing was launched, and the product was termed as Business Information Warehouse. SAP has attempted a version of reporting tool in 1992 itself, but it was not commercialized because it was not that efficient. And in 1998 October, they have released 1.2a version for BIW. So the actual version which we are using now is 3.0a for BW, which was released on October 2001. So BI, either it is 7 or 7.3, it still has the traces of 3.0 BW, and the business content we use is also from there. So BW 3.5 is every BW consultant is familiar with 3.5 generally, because we somehow have used BW 3.5 directly, because SAP still has business content in 3.5 version itself, even though we are using 7.0. And if you have started from 7.3 version, then you won't see 3.5, because the business content data flows are changed to 7.0 in 7.3 version. Significance and overview of SAP Netweaver Platform. SAP Platform allows organizations to build new business solutions rapidly while realizing more business value for existing IT investments. SAP Netweaver supports new cross-functional business processes and helps to lower the TCO, total cost of ownership, by reducing the need for custom integration. What does the custom integration means? It is if, for example, if the business needs the solution which is custom solution, then they have to create some their own custom data flow for the data, so that the cost effectiveness is provided by SAP. That is why customers are attracted to SAP Netweaver Platform. It offers complete lifecycle management for all of your applications. It is also the foundation for enterprise services architecture and helps align people, information and business processes across organizational and technological boundaries. The components included are security. It provides security and people integration by multi-channel access and portal. Portal, we can use it through portal and from the remote areas. So this is very helpful feature in business and collaboration. Information integration by BI tool. The information is very much integrated and enhanced, so the reports the highly sophisticated reports are used by managers now, and the different managers across the organization can see the same reports or see different reports. There is a lot of flexibility, and the SAP BI content, which is the main reason why most of the clients would switch to SAP from other databases. So because SAP is providing the business solutions which are the best in market. For example, the data marts like FI, HR and all integrated into the ERP. So this is what customers are liking more and more, and they are switching to SAP from other databases. It gives knowledge management and master data management. So that is the Netweaver, SAP Netweaver, which has a multi-channel access, people integration, information integration, process integration, and application platforms like J2E and ABAP, both of them in one platform. So process integration, integration broker, and business process management. Application platform, it has Java and ABAP and connectivity. Lifecycle management, customizing, software change management, system management. So we come to the architecture of SAP. SAP is R3 is based on 3-tier client server model, represented by database layer and application layer and presentation layer. So what is database layer? It consists of a RDBMS, a relational database management system, which accepts the database requests from the application layer and sends the data back to the application layer, which in turn passes on the same to the presentation layer. Presentation layer is nothing but the GUI. The application layer interprets the ABAP programs. For example, the commands, it interprets into getting the inputs from them and providing and processing the output to them is the main purpose of application layer. And the presentation layer is what is installed on the typical workstation of a user. This is nothing but the SAP GUI, which when started provides the user with the interface of SAP R3 menus. This interface accepts the inputs from the user, passes the same on to the application server, processes the inputs and sends back the output. The application server is the SAP Web Application Server, which we will refer to as WebAS. It is a development and runtime environment at the same time and has all the components of a typical application server, such as database and communication interfaces, log management, and job and process control, as well as tools for system administration. The execution of processes in SAP BW is based on the runtime environment of WebAS, in which the functionality was developed. It can also be enhanced by proprietary development through its integrated development environment. So, for scaling and load balancing, it is possible to use not only one but several application servers to direct dialog and background processes to the application server that has the least load when the process is started. So up to this point, web application server is similar to other application servers, but in 6.4 version onwards, WebAS not only had one development and the runtime environment, it had two of each, one for the ABAP and one for the Java programs. Each of these WebAS components is a self-contained application servers, and they can be used technically isolated from each other. Thus, both WebAS components are full application servers that can be run on identical or different physical hardwares. The system landscape of SAP. A client is the topmost organizational structure which has its own set of master records. A client is denoted by a 3-character alphanumeric code in SAP, and it is a mandatory element. The settings made at the client level, data maintained, etc., are available across the company codes. For example, for one client you have particular settings and authorizations, so that if you have 1 million records, if you want certain 800,000 records should be shown to the certain client, and the certain client should not have some authorization, and he will only be accessing 500,000 records, and the certain client would have all the authorizations, and he must be a high level manager, and he must be accessing all the 1 million records. So according to that, according to clients, you can fix that. Also in SAP, typically you will have different types of clients, namely development client, test client, and production client. In any implementation, it is necessary that you have at least 3 types of clients as mentioned above. I mean, for example, you can create new objects and scrap them, data flows, and delete them, etc. So you can play around in development client, and you can actually if you want to learn as well, or if you want to see the impact, what would be the impact and all, so you would get that in development client. So we generally use it for that. And in test client, once you have created the data flow in a development client, and when you want to test the data flow by passing the data and looking at the reports and all, then you go to the test client. You transport the data flow to the test client, and then you test it there. In production client, we go live. That is where the actual business data is available, and you load it data in production client, and you use it. It is for the business use. In any implementation, it is necessary that you have at least 3 types of clients as mentioned above. So that's important to have at least 3 clients. As mentioned below, you can have 4 to 5 clients as well, but it is not necessary. A development client is also called a sandbox client. Sometimes this is also termed as play client. So these are the uses of test and production client, as I mentioned. And business trends. Business have become nowadays very vast, due to continuous growing of businesses and innovation in data processing. More and more information is stored in a more detailed format. As a result, there is a need to both reduce and structure this data so it can be analyzed meaningfully. Until now, the goal behind the implementation of classic data processing systems has primarily been the acceleration, cost reduction, and automation of processes in individual business areas. For ERP systems and other software tools now do this in most companies. The result is that these ERP systems, CRM systems, banking and credit card systems, and corporate governance regulations have exponentially increased data volumes needing analysis. So all the businesses are getting data, and there is a lot of need for the data and data gathering for analysis, etc. Nowadays you would have definitely heard about the companies like Facebook and different social media websites, etc., which worth $1 billion. Google, for example, Google is scrapbooks and all. Google wants to buy such websites for 6 billions, 4 billions, etc. That why would Google do that? And they can actually create their own, right? They have such a innovative people and they have such a workforce with them. Why would they overtake something which a single person or which 2-3 people have innovated? The reason is data, guys. That is only because of the data that they have got. They value the data, they pay the price for the data, and they acquire the company and they give their own brand name. For example, YouTube, etc. Everything Google has acquired for themselves because they have been such a hit, and so the Google wants the users and data for them, so that they can include everything in their search engines, etc. So Google can become bigger and bigger. So that is the idea, and the data they get is what makes value. So some consider this as a negative as well. Others, like SAP, think that this enormous amount of electronic information is a huge benefit. So decision makers in modern globally operating enterprises frequently realize that their survival depends on the effective use of this information. Unfortunately, this information is often spread across many systems and sometimes many countries. Thus, making effective use of information is extremely difficult. So that is where we come into the picture, the data warehousing and then business warehousing, business intelligence, everything. So data analysis demands a historical perspective, because ERP is a transactional processing OLTP system, online transactional processing. So what happens there is we are getting the data from the legacy systems. Legacy systems are something which, when you go to the supermarket or when you go to the bank or ATM, you see the legacy systems. You only operate in DOS prompt or something like that, and you enter the data, and the data sits in the computer somewhere in the database, and that database pumps data to the ERP systems, and the data comes into the SAP ERP, ECC, R3, and from there we pull the data, historical data, so that it won't be a burden on databases, and we pull the historical data and we make data analysis. So data analysis demands a historical perspective. What was my total revenue in the last 5 years? These are the questions a manager typically have. And is it financially viable to continue our manufacturing unit in EU? I would like a prediction of customer turnover for the upcoming year with justification for the numbers. All these are questions which typically manager want data to answer the information he wants for such questions, and the historical perspective gives that information, gives that answers. So data can be divided into two types of data: operational and historical. Operational data that works, that is data that is involved in operations, frequent updates and queries, fragmented and local relevance, point queries accessing individual tuples. Operational data answers the following questions: what is the balance in your account? They are individual tuples, they are much more current questions. What is the balance in your account? And I want a bank statement with last 10 transactions. And what is the salary of Mr. Smith? Simple questions like this, the operational data can answer, and that is called OLTP data. And the historical data is the data that tells about the performance, etc. Very infrequent updates, integrated data set with global relevance. I mean, we generally load historical data, for example, every day. When a transaction happens, every second we can load the data for 4 hours, once in 4 hours, or once in a day, like that. So it depends on the business how they want to view the data, and it depends on the manager's requirements, etc. So analytical queries that require huge amounts of aggregation, performance issues mainly in query response time. So historical data answers the following questions, right? Which are the peak times and which are the off-peak times for our business? What was my total revenue in last 5 years? Whereas in operational data, we can only get the bank balance or last 10 transactions, 5 transactions, current data. Here we are getting historical data. So that's the difference. So it answers questions like that. So is a category of applications, BI, business intelligence, and technologies for gathering, storing, analyzing, and providing access to data to help enterprise users make better business decisions. BI applications include the activities of decision support systems, query and reporting, online analytical processing, OLAP, statistical analysis, forecasting, and data mining. Data warehouse. A warehouse is a subject-oriented, integrated, time-variant, and non-volatile collection of data in support of management's decision-making process. This is said by Bill Imon. We are talking about the data warehouse now. A data warehouse is a copy of transaction data, specifically restructured for queries and analysis. This is said by Ralph Kimball. And we have Ralph Kimball's bottom-up approach, which is creating data marts and then the data warehouse. Bill Imon create a data warehouse and then the data marts. It is a database used for reporting and analysis. The data stored in the data warehouse is uploaded from the operational systems. There are two leading approaches to storing data in the warehouse: the dimensional approach and the normalized approach. For example, Ralph Kimball has given the dimensional approach which we use in data warehousing, business warehousing, by having extended star schema and star schema built on the idea of Ralph Kimball. The normalized approach is Bill Imon's approach, in which it is stated that the data warehouse should be modeled using an ER model or normalized model. So a data warehouse has the following properties. What is normalized? Normalized is without redundancy, and denormalized is with redundancy. I mean, it may have redundancy for the denormalized. Normalized means no redundancies, no duplicates. So a warehouse has following properties: read-only access. Users have read-only access, meaning that the data is primarily loaded into the data warehouse via the extraction, transformation, and loading ETL process. So cross-organizational focus: data warehouse data is stored persistently over a particular time period, and data is stored on a long-term basis, designed for efficient query processing. Business intelligence systems have the following objectives: standardized structuring and display of the business information. So decision makers want urgent reports, so they require an up-to-date and comprehensive picture of the data. So that is what we provide by using BI. So simple access to business information via a single point of entry, and highly developed reporting for analysis with self-service for all queries. Quick and cost-efficient implementation. When implementing, we can implement cost efficiently by using BI content, etc. So it is quick, it is cost efficient, and it is flexible, and there is a drill down, drill across functionalities in BI, etc. A lot of features are there in BI, so it is very preferable. High performance environment, data modeling for heterogeneous sources. Relieving OLTP systems. In the past, OLTP systems were strongly overloaded by having to store data and analyze it at the same time. And there are, in OLTP systems, there are transactions happening every second, or it depends on data. And on such a platform, on such a system, you cannot keep a lot of burden on that system by providing reporting there, etc. Because when you have a query like what is my revenue for last 2 years, and it needs 2 years of data, and you can't keep that much data there. So you need to relieve the OLTP systems. Even though you keep it, it takes a lot of time to retrieve data, etc. So there are a lot of problems. So there was a need for a tool, and they've developed BI. Differences between OLAP and OLTP systems. Level of detail. The OLTP layer stores data in a very high level of detail, whereas data in the data warehouse is compressed for high performance access. So archiving of data is there, means it is stored with minimal history. The data warehouse data warehouse is used for historical data. And changeability, integration, normalization are the features why we use BI, read access. So that is the difference between OLTP and OLAP systems. Are target efficient through automation of business processes, etc. Generating knowledge, competitive advantage as by giving historical perspective, and view of data. In OLTP systems it is detailed, and in OLAP systems we can aggregate the data frequently. Age of data in OLTP systems it is always current, in OLAP it is historical. In database operations like add, modify, delete, update, and read, all are, we can use that in OLTP systems, but we can only read the data in OLAP. We don't change the data in OLAP. Though we can change the data, we don't actually change the data unless there is such a need or error in that. So typical data structures are relational, flat tables, high normalization for OLTP, and for OLAP multi-dimensional structures are there. Archiving is available in both the systems. Integration of data from various modules and applications, minimal for the OLTP systems and comprehensive for the OLAP. So what are the topics you want to learn for the data warehouse? If you want the prerequisites, the topics, then I would just run you through that. SAP BI, I would suggest these are the list of prerequisites you want. And these prerequisites are like you have to learn data warehousing lifecycle and data warehousing so lifecycle, ER modeling, fact tables and dimension tables and their types, schemas. These two are important, and this one is also important. Slowly changing dimension and dimension modeling in different domains. It's okay if you want to learn something else like ER modeling, it doesn't matter. and ETL process is what we are going to discuss, so it is important here. So these are the prerequisites, guys, and if you want to note the list, you can note the list, and I'm going to tell you the data warehousing life cycle by means of presentation slide, so that I can write here. No. We have sources from S1 to like SN, right? So for the sources we need to create a middleware. I will show you. For example, we have sources, right, and then we would generally create a middleware, combine all sources at one virtual place, that is called as middleware. And we have data profiling, then we have data quality, and we have extraction. We do extraction after that. This is the life cycle of data warehouse typically. Transformation, and then we load data to the data warehouse. Here to here, first sources and the virtual sources will be available in data middleware, and the data will be used as data profiling, and then the data quality, and then we extract the data, then you transform the data accordingly, and then you directly load the data. And these are the things, these are the activities we do. And we load it into three types of warehouses are there available. there is these are arranged in and there is HANA database as well. It is arranged as row tables and column. So this is typically a HANA star schema where you will see rows and columns, row tables and column tables. You will have extended star schema based warehouse management in BI, and in non-SAP you will have dimensions and facts like that, aggregated tables, dimension tables and fact tables in non-SAP. So typically it is like that. It is like that. For example, sources to middleware, and from middleware to data profiling, data quality, extraction, transformation, load. This is the typical life cycle of data warehousing generally speaking, for everything, for non-SAP or for SAP or HANA DB. So I will talk about the SAP BI basics again. For there is another file I've created for that, and after that you can go to the videos of practical knowledge like master data loading, flat file loading, and business content, etc. See you guys then. Until then, bye.